What is going to get back? You have to know that. That's when you just. Oh, yeah. If you talk about something, just all the boring. Which I'm not saying you shouldn't do these assignments, but. And some of the great and some are stuff. Yeah.
So what you guys have been doing for the last, I think, 2 days is graphing quadratics in standard form. So standard form is the one you've been using. Y equals a x squared plus bx plus c. So that's the one you've been trudging through, finding a and b and then doing opposite b divided by 2a. Sometimes that's a lot harder than other times. And then you get your x value and you plug it back in, and then you trudge through all the fractions and all that stuff. And then eventually you find the vertex, which again, with some problems takes 30 seconds and some problems it takes 3 or 4 minutes. So that's what you're familiar with right now. Starting today, we're going to talk about another format, which you're going to like approximately 83 times as much. So where we're going to go with this eventually is you're going to quiz on Thursday over the 2 things that are about to be on the board. Because today's lesson is so easy, like it's totally easy. And then we'll quiz on these 2 things Thursday. And then next week, I will teach you how to turn the bad one into the good one. And that's a pretty mathematical thing. Like there's a lot of meat on that bone. So in the past, I've tried it kind of both ways. I've done one quiz where you have to graph some in standard and then some in vertex. But once you know the trick to turn standard into vertex, that's kind of a tough pill to swallow because then you just kind of sit there and think, why don't I just turn them all into vertex? And that's not really what I'm wanting to do here. I want to make sure that you can do both of these before I sort of show you the ending of this. So for today, vertex form looks like this. Y equals a times x minus h squared plus k. And it looks harder. I mean, if for no other reason than that there are these new variables h and k. But the thing about h and k, what you'll commonly see, like you'll see this in all levels of mathematics, h and k are numbers that are commonly used to refer to a specific point, the vertex. So if you see those letters, there's a pretty good chance that we're wanting you to make an identification. And here's the identification. When you're given a quadratic equation or quadratic function in vertex form, you can rest assured that the vertex is at the point h, k. So H and K, I know they're kind of the new guys and they can be a little bit scary, but they're actually really nice because this particular format of quadratic just literally gives you the vertex. You don't have to do any math at all. None. Zero. I mean, we'll have to do a little math when we go to make the graph, the buildy part, But before that, you don't have to do any of the negative b over 2a, plug it back in kind of stuff. So for example, and I'll just sketch with you since I didn't give you graph paper today. So I'll just kind of do what you're doing and I'll just sketch on blank paper like this. So if I gave you a quadratic like this, if I said y equals 2 times x minus 3 squared minus 1, you know the vertex before you're done writing it down. No negative b over 2a, none of that kind of stuff. In fact, b doesn't even make sense here because I'd have to expand out x minus 3 squared, which I don't want to do. Does anyone know, based on what you see up here in purple, what the vertex of this particular quadratic parabola would be? That's what I would have said if I were you too. Correct. And if you read it again really carefully, This minus sign, I'm going to point to it with a little yellow arrow right up here. That's one of those times in math when we have to think about making something equal 0. And so if you claim that the vertex is here, don't write this down, you can prove to yourself that that's not true by just putting -3 back in because the parentheses won't get centered out. What we're trying to always do is make things centered or symmetric or zero them out. And if you put -3 up where the little yellow arrow is pointing, right up here, I'll underline it for you. What's -3? Or what am I trying to say here? -3 right here. If you put -3 right there, what's -3 minus 3? -6, which is not what we want, right? If we want this, I should have underlined this. If we want this to equal 0, what value of x minus 3 would equal 0? 3. So Landon, I did hear you say that. Nice job, by the way. So the vertex we see right away is at +3, but the -1 is unaltered. Anytime you see a plus or a minus at the end of a function, all it does is move things up and down, right? It's just there's nothing to understand about that. So the one inside is the one that we flippy dippy, and the one on the back we just take and steal it. So when I go to graph this, I don't have to do any math at all. So what we're going to do is we're just going to make a quick sketch. So the first thing we're going to do is go to our vertex. How do I get to that point? 3, -1. Right 3 and down 1. So maybe right about here, something like that. How nice is that? Like the vertex just gets handed to you on a platter. Like, well, yes, please. Thank you. And then the thing about it is kind of like before, this stuff that I'm about to completely vandalize no longer matters. Okay. That A is your guy. He's been your guy as far as building, and he will continue to be your guy. So when I go to graph this, I'm just going to do what I've done before, and that is I'm going to follow the modify your ups. So like if I went out 1, I would normally go up 1. We're going to go up 2 like this. Okay. And when I go out 2, I'd normally go up 4, right? How far up am I going to go? 8. So I'm going to go out 2 right about here, and I'm going to go up a whole bunch, like 8. And this will be one of these ones that's pretty hard to graph because with everything being so tightly packed together. But that's how easy vertex form is. And so you just sketch it like that, and you're done. Okay. Vertex form is fantastic. I don't know if you clearly understand that. The first example for a lot of people can be a little bit like foggy. So let's do another one. That's how quick it is. So let's do y equals -1/2 of x plus 5 squared plus 2. First off, immediately, where's the vertex at? No, it is at -5 and +2. And again, the idea is like we did with quadratics when we're solving equations, we want to make something equal 0, right? And the only way to make x plus 5 equal 0 is if x equals -5. So the x coordinate you switchy, right? And then the y coordinate you just leave the same. You just take what you get. And so it's that quick. When you go to make a graph, you just simply go to where the vertex is. So in this case, I'm going to go left 5 and up 2. So wherever that may be, maybe right about here. And then talk to me about the build. When I go out 1, how far down will I go? Down a half. So I'm going to go out 1, down maybe a half a point like this. And so we're going to have a chonker, right? And when I go out 2, how far down will I actually go? How far out? Yeah, how far out would I normally go if I went out 2? I'd normally go down 4, but I have to take half of that, right? The negative makes it go downwards, of course. The half is a squasher. So we're going to go out 2 and then down only 2 like this. And so again, unlike the last one, you can see you're going to have a parabola that is a little bit on the, ooh, that was a nice one, a little on the thicker side. Okay. You're always going to spend your time on the math of the build with vertex form. I mean, unless it's a default one like this. If I had like y equals just x plus 1 squared minus 3. I mean, this is easy peasy, right? First off, where's the vertex? Good. I didn't hear any incorrect answers that time. That was good. Third try, and I think we finally got it. Switch this one. So our x coordinate's -1. Our y coordinate, we just keep the same, -3. And then when I go to my vertex, which is at left 1, down 3. So maybe right about here. Oopsie, right about here. Then what's my build? Mhm. It's the normal one, right? So like if I go out 1, I just go up the normal 1. If I go out 2, I go up 4. And so this is just our standard default unmodified parent function, just relocated someplace else. Okay. Do you have any questions about vertex form? You will spend 1% of your time finding the vertex, which is a complete flip-flop of standard form. 1% of your time will be just grabbing the vertex. The other 99% will be usually doing the math and figuring out how far up or down you're supposed to go. Right. And just one last thought on this. I don't know that we need to make a graph on this one, but I get a lot of questions about this. So let's say we had like y equals 4/5 of x plus 2 squared minus 3. Right away, where's the vertex? -2, -3. So the -2 comes from the switchy switch here. And the -3, we just grab off the back, right? That's not what this is about. What this is about is the ups. And so this is primarily where my questions start. I mean, once we filter out all the other stuff, then the questions are always about the math. And so if you think about it, so like if I go from my vertex and I go out 1, how far up will I go? I will go 4/5 because that's 4/5 times 1, right? Remember the normals, I'll put them here in the middle in yellow. The normals are 1, 4, 9, 16, etc. So if I go out 2, I normally would go up 4. How far up am I going to go? You don't need calculators for this, by the way. I know some of you love them, but you don't need them. Yeah, this is usually where we get a little hung up. So the math of it is this. We take the normal, which would be a 4, but we multiply it by the scalar, which is 4/5. And then we hearken back to the old 5th grade. How do you multiply a whole number by a fraction? You put the whole number over 1, and then you look for anything you can cross out. Do you see anything you can reduce? I don't. The tops are 4s and the bottoms are 1s and 5s. There's nothing that can reduce. So in this case, we would say, okay, we're going to go up 16/5, which we should in this case think of as 3 1/5. Normally I frown on mixed numbers, but when it's a place I have to go to, something I got to count, I like mixed numbers make more sense. You tell someone you owe me 16/5 dollars, they're going to look at you like you're on the crack, right? But if you say, hey, you owe me $3.20, well, that makes more sense, right? Well, there are times in math where these things just kind of speak for themselves. What if I went out 3? My normal would be 9. So I'm going to take my normal and again multiply it by the scalar, which is 4/5, and that is 36/5. What does that equal as a mixed number?
I'll say.
Yeah, 5 goes into 36 7 times with 1/5 left over. So I go up 7 and a little bit extra. If I went out 4, my normal would be 16, right? So I take the normal 16 and I multiply it by 4/5. I chose an ugly fraction for this one because I just want you to understand that you're not doing something wrong if things don't like cancel and come out all pretty, right? So what is 16 times 4? 16 times 4, thank you, is 64, and 64/5. Then you just math it. And you all know that 5 times 12 is 60. So 5, we can say, goes into 64 12 times with 4 left over, right? Any questions about that? So it's the same old, right? And these are always, you'll always spend your time when there's an ugly number like this, that's going to be our only source of concern. It's just dealing with those. Okay. Any questions? All right. I'm going to hand out assignment number 31 and you're going to work on that. And then just know that we're done. Like this is it. No more class days for learning how to do this. Right now, you might be working on 29 and 30, maybe. Should have those getting done. Then you should finish this one today and then know that tomorrow and Thursday are not like work time for these. They are practice quiz. Got it? Any questions? Okay, cool. So, so just to get you started, so we're gonna first off just write here vertex at, and then what are the coordinates of the vertex? 1, 4. So step one, we're going to go to that point, which is right 1 up 4, and we're going to put a dot. Like I said, the math now is where you're going to spend your time, but this is high school, so we're not going to struggle too much with fractions anymore, right? Um, if I go out 1, how far up will I go?
Half.
Yeah, the half of what I normally would, which is exactly a half, because that's half of 1. So my vertex is here at 1, 4. And when I go out 1, I just go up half of my normal, which is right there. And when I go out 2, how far up will I go? I would go up 4, right? Good job, Parker. So I'm only going to go up 2. So I'm going to go out 2, and then I'm going to go up half of 4. And you could arguably squeeze another one in here if you wanted to. It's better. It's always better, I think, to have more points. But I understand, like, if you didn't put this other one on a test, I wouldn't hold it against you. I personally, though, like more dots to connect. I feel like I can make a better graph. So I am going to go out 3. 1, 2, 3. How far up will I go? 4.5, right? Because that's half of 9, half of my normal. So I'm going to go out 1, 2, 3, and then up 1, 2, 3, 4. And I'm just going to kind of fudge what I think a half a space above would look like. Kind of like that. That's not a crime. If it was like 2.5 above, then I probably wouldn't do that. But it's close enough where I like to have more stuff to hang my shape on. So that's the gist. And then of course now you've got the really hard part, which is trying to make the graph. Oh, Nelly. Ooh. Oop, I missed. There we go. We'll call that good. All right. Well, I'm going to keep the recording alive and paused. Take a look at number 5 real quick. Please look at 5 so you don't ask this question in 7 minutes. Look at number 5. What's the vertex?
1, 4.
Yeah, I just wanted to make sure. I figured some people might say, hey, this is different, right? You do know there's a 0 at the end. You just can't see. So the vertex is at 1, 0. And then it's just business as usual. Okay. Well, let me know if you need more help.